All right. Hello, everyone. We are going to continue on with section 3.9 today. Section 3.9 is on antiderivatives. Antiderivatives. And if you recall, the process of antidifferentiation is essentially, you can think about it as you start with the derivative and you work backwards and find the original function that it came from. We talked about a few rules last time, a few rules of antidifferentiation. We said that if you are given this elongated S symbol, that's the integration symbol, and that is in front of a function f of x dx, then I can apply those rules of antidifferentiation and I get what's sometimes called a primitive or an antiderivative, f of x plus c, and that occurs if f prime of x is equal to f of x. Or technically, I could say the derivative of f of x plus c, because the derivative of c is 0 because c is a constant. We're going to introduce a few more rules now and work some more problems. Okay? So, if I am asked to say find the antiderivative of the cosine of x with respect to x, I have to think about what function was differentiated to find cosine. Well, that function is the sine of x. I'm not going to do the intro examples for these. I'm just going to write down what the rule is. The antiderivative of cosine is sine, and because I'm taking the indefinite interval, I have to add that constant c to the end. Similarly, antiderivative of the sine of x with respect to x is equal to the cosine of x plus c. The indefinite integral of the secant squared of x with respect to x, I have to think about what function was differentiated here. If I differentiate the tangent function plus c, I get secant squared. I'm wanting to find the indefinite integral of similarly cosecant squared of x with respect to x. Then I get the derivative of cotangent is negative cosecant squared, so the antiderivative of positive cosecant squared should be negative cotangent of x plus c, which reminds me, antiderivative of sine of x actually should be negative cosine of x, because the derivative of cosine of x is negative sine, therefore the derivative of negative cosine should be sine. Okay, moving on. What is the antiderivative of the secant of x times the tangent of x with respect to x? Well, the function that was differentiated to get secant tangent is the secant of x plus c. And finally, the indefinite integral of the cosecant of x times the cotangent of x with respect to x is equal to negative cosecant of x plus c. Okay, so there is kind of a somewhat full list of our rules for antidifferentiation. Okay, so let's again do some problems using these rules and using the rules that we already covered. Let's do this example. Let's find the indefinite integral of negative 2 times secant of x tangent of x plus 4 secant squared of x dx. x. Okay. So first thing I can do is I have two terms here, so I can split this up, and I can move any constants out front. This is equal to -2 times the integral of secant x tangent of x dx plus that constant 4 I can move out front of the integral symbol, 4 times the antiderivative of secant squared x dx. Okay. This part, I have a rule that tells me how to differentiate it, or take the antiderivative rather. This part, I have a rule that tells me how to take the antiderivative. I can apply those rules that we've just covered. So this is equal to -2 times antiderivative of secant tangent is the secant of x plus c, that I can just tack the c on the end of this whole expression, plus 4 times the indefinite integral of secant squared of x, which is the tangent of x. And then that whole thing, I can add c to it. I'm going to rewrite it without the brackets. -2 times secant of x plus 4 times the tangent of x plus c. Okay, so this is the indefinite integral of that original function, -2 secant tangent plus 4 secant squared of x dx. Just a little note on notation. Very similarly to what we did for differentiation, here between this step and that step, notice that I applied a rule of antidifferentiation. I did what this symbol was telling me to do, and I used the rule that said, well, the antiderivative of secant of x times the tangent of x dx is the secant of x plus c. As soon as I apply that rule, I dropped the integration symbol and the dx part. Because the reasoning for that is because that symbol tells me I still have to apply the rules of integration or of antidifferentiation. But once I write down secant of x instead of secant tangent of x, I don't need to apply those rules of antidifferentiation anymore. So I better get rid of that symbol to tell people who are reading it, hey, don't do it anymore. Don't apply those rules again. And I did something similar over here on the right-hand side. I know by one of my rules of antidifferentiation that the indefinite integral of secant squared of x is the tangent of x. So as soon as I write down tangent of x instead of secant squared, I must drop this symbol and that symbol. Okay? For the integral of those two functions, the indefinite integral, I only need to add one constant c to the end. All right, let's do another example or two. Let's do this, and I'll also make a note on notation here. If I want to find, maybe I'll use black, not red. Let's find the antiderivative of x to the -1 plus, or excuse me, minus the sign. Oh, sorry. I wrote that down incorrectly. Let's say u to the -1 minus sine of u du. And I intended to write down u in the first place just to make a note that this term, this is the term that tells me what variable to use. Because this variable u matches the variables in the integrand, this expression here is called the integrand, that means I can apply my rules of antidifferentiation just like I did before. If this symbol did not match these variables, I could not proceed as I did before. I would have to figure out whether this variable related to the other variables that were in the expression, or if they didn't, before I proceeded to use the rules. But fortunately for us, these match. The variables match. Variables match. So we can proceed with applying the rules of antidifferentiation. Apply rules of antidifferentiation. Differentiation. That is a very long word. Okay, so let's proceed with that. This is equal to the antiderivative of u to the negative 1 du minus antiderivative of sine of u du. I have rules that tell me how to find the antiderivative of both of those. That first one, I'm taking the antiderivative of a variable raised to that very specific power of negative 1. If I have that very specific power of negative 1, I know this is equal to the natural log of u, or natural log of absolute value of u if you prefer, minus antiderivative of sine, which is negative cosine of that variable u, and then I can add c to the end of that. So this becomes natural log absolute value of u plus the cosine of u plus c. That is my antiderivative. All right. So for all of those, I was able to, for both of those, I should say, once I split up the expression into two different, or I guess in the previous case, I also had two different integrands, I was able to apply rules of antidifferentiation. Sometimes you will have to, as we saw in class last time, use algebra or knowledge of trigonometry in our case today to rearrange the integrand so that it fits in the form of one of the rules that were given. So these next couple of examples will deal with that. But I think that we will pause this video and do the next couple of examples in another video.